Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of overall reaction order. Whenever we're looking at a rate law like we have here, we have an overall order that can be calculated by looking at the sum of x plus y. Once we know what the overall reaction order, some of the more common orders have equations for half-life, the integrated rate law, units for k, and what to do to the y-axis to make it linear. I strongly suggest that you memorize these things by making some note cards. In doing so, you will make your life much easier. Rarely will a chemistry professor, especially in college, tell you that it's first order or second order. Okay, so here are the different orders of the reaction that you will need to memorize. I suggest, again, using note cards. For one side, you will have 0, and then the other side, you will have all of these things listed. Again, half-life is the amount of time it takes for half of the sample to decay, for it to reach half the original amount. A sub t is the integrated rate law, and basically, except for these last two, a sub t equals this, or this. And it's the way of getting the concentration at any given time, knowing the initial concentration and the rate constant, or any manipulation of that equation. They could give you the concentration at the time it took to get there, the initial concentration, and ask you to solve the rate constant. Either way, you should be able to manipulate an equation by now. Here you can see that these are some reciprocal equations, so that's why they actually have 1 over AT. These ones were actually AT equals. And basically, they're the same equations. This is the nth term, the general term that works for everything except for the first order is a little disobedient and doesn't follow this general rule. Okay? Again, memorize these units. Memorize the units for 0 order rate constant versus first order versus second order. So if you're given a rate constant and its units, be able to recognize that it's first order because it's seconds inverse. All right? And sometimes you might be asked the question, what do we need to do to the data to make it linear? This is what you need to do for 0 order. Here we just need the concentration of A, whereas a first order reaction would not be linear if it was just concentration. But when we take the natural log of it, it does become linear. And this one, when we take 1 over the concentration, it becomes linear. All right? So from those, you can also have a rate equation. Let's see if we can fit it all together. There we are. And here is the overall rate law for 0 order. It's K times concentration of A, and then A squared. Ooh, there should be a little n there. Let's add it real quick. Ka to the n. Okay? So I hope I've clarified things for you. We'll do examples of each order reaction and be asked to either, find the concentration at time t given the rate constant, the initial, or some other variation of any of these variables. The key to this is to practice as many of these as you can, and the more you do, the better off you'll be. I hope I've eliminated any doubts you might have. Thank you, and have a nice day.